All right, so get this. Schrödinger's cat, the cat in a box, alive and dead at the same time. Crazy, right? But that's what we're going to unpack today. Don't worry, though, it's just a thought experiment. No cats were harmed in the making of this deep dive.
Well, it's this thought experiment that really highlights how strange quantum mechanics can be. We're going to explore the history of it, the science behind it, and even the philosophical stuff.
Sounds pretty heavy. Where do we even start with something like this?
It all kind of kicked off in the early 1900s when physicists were seeing things in the subatomic world that just didn't make sense. Like classical physics just couldn't explain it.
Right, totally different rules down there.
Yeah.
What were some of these big discoveries that changed everything?
Well, one of the biggest things was Max Planck. He found out that energy, we always thought it was this continuous flow, right? But he found out it actually comes in like these little packets.
So not like a smooth flow, more like.
It's like if you could only pay for things with dollar bills, no coins, no change, just specific amounts.
Ah, I see. So energy is more like stair steps than a ramp.
Exactly. Then you've got Einstein, and his work on the photoelectric effect just threw another wrench in the gears. He proved that light, which we thought of as a wave, could also act like a particle.
So, like, it has two sides.
Exactly. Like, think of water. It can be a flowing river, but it's also made of individual drops. Light's kind of like that. Then, to add to the confusion, Niels Bohr comes along with his model of the atom. And in his model, electrons can only exist at very specific energy levels. No in between.
Like they can't just hang out wherever they want.
Nope. Very specific spots, like a bookshelf where you can only put books on the shelves, not just anywhere.
So all these discoveries were pointing to a whole new set of rules for the subatomic world.
And those rules, that's what we call quantum mechanics. It's a whole different way of thinking about things.
And that brings us to the Copenhagen interpretation, right?
Mm-hmm.
Doesn't that say that particles can be in multiple states at once until we measure them? I mean, is that even possible?
Well, the Copenhagen interpretation, which was really pushed forward by physicists like Niels Bohr and Werner Heisenberg, it says that, until you measure a particle, it doesn't really have a definite state. It's more like it's in all possible states at the same time, and we call that a superposition of states.
Oh, okay. I'm trying to wrap my head around this. So like a coin flip, before you look, it's both heads and tails.
Yeah, kind of like that. It's only when we actually measure it that the particle chooses one state.
And that's where this Schrödinger's cat thing comes in.
Right. Erwin Schrödinger, he was a big name in physics, and he wasn't really a fan of this Copenhagen interpretation.
Yeah.
So he came up with this thought experiment to show how absurd it could be.
So he was like, if you think particles can be in two states at once, then what about a cat?
Yeah, basically. He wanted to show that using quantum mechanics on everyday objects led to some pretty crazy conclusions.
Okay, I'm hooked. Tell me more about this experiment. How does it actually work?
All right, so picture this. You have a box completely sealed. Inside, there's a radioactive atom. It's got a 50-50 chance of decaying within an hour.
Okay, and?
There's also a detector in the box. If the atom decays, it triggers this mechanism that releases a deadly poison. Oh, and there's a cat in there, too.
So the cat's life is basically riding on this random atom thing.
Exactly. Now, if we follow the Copenhagen interpretation until we open the box, that atom is in a superposition, both decayed and not decayed at the same time.
Wait, so it's connected to that superposition too?
Right, because the cat's fate is tied to the atom. It's also in a superposition, both alive and dead until we look inside.
A real cat, like in two states at once. Now that's just weird.
That was Schrödinger's whole point. He thought it was crazy that we could even think of a cat, something big like that existing in this quantum state. Like subatomic particles, sure, but a cat. That's where he drew the line.
Okay, but hold on. Wouldn't, the air in the box and stuff mess with the whole superposition thing? It's not really isolated in there, is it?
You're right. That's where decoherence comes in. Basically, the cat's always interacting with stuff in the box, like the air, the box itself, even light. All those tiny interactions, they kind of act like little measurements.
So it's like the environment is constantly peeking in, so the cat has to choose a state, alive or dead.
Yeah, you could think of it like that. And that's why we don't see these weird quantum states in everyday objects. It all gets sort of averaged out at larger scales.
Okay, so real cats aren't stuck in some quantum limbo. Phew. But earlier you mentioned that this superposition thing has real-world applications. How does that even work?
Right. Well, one of the coolest areas is quantum computing. You know how computers use bits, 0 or 1?
Yeah, like the basic building blocks?
Well, quantum computers use qubits. And thanks to superposition, a qubit can be 0, 1, or both at the same time.
Whoa, that's like a bit on steroids. What can you even do with that?
Think of it like searching a maze. A normal computer has to go down each path one at a time. But a quantum computer, because of superposition, can check all paths at once.
That's incredible. What kind of problems can these quantum computers solve?
Problems that would take normal computers, even the best ones, millions of years, like simulating molecules to design new drugs or breaking the encryption that keeps our online data safe.
So we're talking about changing the world kind of stuff.
Definitely. Google actually built a quantum computer that did something even the most powerful supercomputer couldn't. They call it quantum supremacy.
So from Schrödinger's cat to world-changing tech, huh? That's wild. Are there any other applications in the works?
Absolutely. There's quantum cryptography. It uses superposition and entanglement to create super secure communication. It would be almost impossible to spy on messages sent this way.
So like the ultimate privacy.
Exactly. And then there are quantum sensors, super precise ones, like atomic clocks. They're used for GPS and stuff.
Okay, but what do clocks have to do with quantum mechanics?
Well, they work by measuring the behavior of atoms at the quantum level. And that lets them measure time incredibly accurately.
So super precise timekeeping because of quantum mechanics. That's pretty cool. What else can these sensors measure?
Oh, all sorts of things. Gravity, magnetic fields, even tiny changes in temperature. Way more accurately than anything else.
Wow, all this makes you wonder what other technologies will come out of this. I mean, could we ever teleport things using this stuff?
It's not as far-fetched as it sounds. Scientists have already teleported photons, those particles of light.
Wait, really? How does that even work?
Well, it's not about moving the object itself, but more about transferring its quantum state to another particle, even if they're far apart.
So like moving information instead of matter.
Yeah, kind of like that. While teleporting people is still science fiction, for now, this technology could totally change how we communicate and compute.
Okay, my mind is officially blown. But this whole Schrödinger's cat thing, it's not just about cool tech, right? It also raises some really big questions about what's real and how the universe works.
Absolutely. If a tiny particle can be in multiple states at once, what does that mean for the world around us? Does reality only exist when we look at it?
Whoa, are we like shaping reality just by observing it? That's kind of deep.
It is. There are different interpretations of quantum mechanics that try to answer these questions. Some, like the Copenhagen interpretation, say that reality is all about probabilities, not certainties.
So we can only predict the odds, not the exact outcome.
Right, and then there's the many worlds interpretation, and it's even wilder. It says every time we make a quantum measurement, all possible outcomes happen, but in different universes.
Wait, so there's a universe where Schrödinger's cat is alive and another where it's dead. Like infinite parallel universes.
Yeah, that's the basic idea. It's pretty mind-blowing, and physicists are still arguing about it, but it's one way to explain the weirdness of quantum mechanics.
Wow, that's a lot to think about.
Definitely. But that's what's so fascinating about quantum mechanics. It pushes the boundaries of what we know and forces us to consider things that seem impossible.
It really makes you wonder about the things we think we know, you know?
It does, and it all comes back to this thought experiment, this cat in a box.
Right. So for those of us who aren't, quantum physics experts, what's the big takeaway? Why should we even care about this Schrödinger's cat thing?
Well, I think it shows us how much we still don't know about the universe. There's so much out there.
Yeah, it's like a reminder that, reality is a lot weirder and more mysterious than we think.
Exactly. We see the world in one way, our everyday lives, but then quantum mechanics comes along and says, nope, at the most basic level, things are way more complicated.
And the crazy thing is, even if we don't fully understand all the physics and stuff, these ideas, these mind-bending ideas, they're already leading to real-world technology.
I know, right? It's amazing. Quantum computers, cryptography, these sensors, they could revolutionize everything. Medicine, materials, communication, even artificial intelligence.
It's almost like science fiction becoming reality.
It really is. And to think, it all goes back to this thought experiment, trying to point out the weird parts of quantum theory. It shows how powerful human curiosity is, our need to understand the universe.
We started with a made-up cat in a box, and now we're talking about tech that could change the world.
It's a great example of how science works, Even the most abstract ideas can end up having a real impact.
So what's next for this field? What are scientists still working on?
One of the biggest challenges right now is building bigger, better quantum computers. The ones we have now, they're really fragile, really prone to errors.
Like one wrong move and the whole thing breaks down.
Yeah, kind of like that. But researchers are getting closer, coming up with new ways to build these computers that are more reliable.
And who knows what we'll discover once we really figure these things out.
It's a super exciting time to be following this field. We could be on the edge of a whole new technological revolution, and it's all thanks to our exploration of this quantum world.
So if any of our listeners are ever thinking about, the meaning of life, the universe, and everything, remember Schrödinger's cat.
Yeah, it's a good reminder that the universe is full of surprises, and sometimes the most amazing discoveries come from the most unexpected places.
And maybe, just maybe, the act of asking these questions, of exploring these mysteries, that's what really shapes our understanding of reality.
That's a nice thought, isn't it? We're not just watching the universe, we're part of it. We're shaping it with our curiosity.
Well, on that note, I think we've come to the end of our deep dive into Schrödinger's cat. Thanks for joining us on this incredible journey.
It was a pleasure being here. Always happy to talk about this stuff.
And to all our listeners out there, stay curious. And remember, even the weirdest ideas can lead to incredible breakthroughs.